So, and now I'm going to go in back here and I want you to listen. Do you hear? You hear the condenser fan running back there, but is the compressor running? Maybe, but I can't tell. And is it running in spec? In other words, is it drawing the normal amps that it should be drawing? Is it getting a speed signal? These are the things that you can at least check out. It probably is, but we want to check on that. So what we want to do is, without having to tear this panel out, your base panel here to access to the compressor compartment, and then you've got the inverter sitting right on the compressor with a 3-harness plug. It's not real straightforward. Instead, you can do a lot of your testing right here at the main control board. You will have to pull the fridge out. There's no getting around that because the board's in back and that's where you're going to be troubleshooting from. But you just have 3 screws, top and bottom, comes right out, the cover comes off, and then you can get access to the board and you can test the supply voltage to the inverter. You can test the frequency of the pulse width modulated signal. You can test the amps on the inverter circuit. So we're going to do that now. All right, so as usual, we start with the schematic. That's our strategy wargaming document. And I've got it loaded right here on my iPad. This is a pretty simple unit. All roads lead to Rome, your main control board that we were just looking at. Up here is the compressor. And you see they're pointing out 3 lines going to the compressor. So indicating it's a 3-phase compressor. We've got what they're calling a drive board. Come on. It is an inverter. So we're going to check the voltage to the inverter circuit, because that's our circuit right here. Right, so we want to check the voltage, and then we're going to check the amps. But there's one more piece. You know, with any of these inverter-driven compressors, you've got your AC supply for the inverter. The inverter is going to take this AC supply, and it's going to single-phase AC supply and chop that up into a 3-phase supply for the compressor. You have 3 different windings in the compressor. Each runs off its own phase of electricity, 120 degrees out of phase, each phase. So it's variable frequency, variable voltage going to the compressor. But we don't have to get it right down at the compressor to measure the amps, because 100% of the compressor amps are coming from the inverter. Therefore, all we have to do is measure the amps right here on the inverter circuit. And then we know the compressor amps. The other thing we're going to do, they're not explicit, and it's an easy thing to miss here, is the pulse width modulated signal to the inverter. And your pulse width modulated signal, it looks like, you know, whatever, different pulse width, whatever, you can measure that as a frequency. And they give us a spec, not so much on the frequency itself numerically. Let's just jump over to that page. Same page, there we go. They're telling us here, main board voltage and frequency. Use a multimeter to measure voltage. Okay, at between 1 and 5, we just looked at that. Pins 1 and 5 over there on the connector for the voltage. And then we're also, in addition, we're going to do current. We're going to look at amps on that circuit. But then they're also pointing out here, be sure to measure the frequency of the CN8 connector, pins 1 and 2. There's only 2 connectors on the CN8 connector, and we looked at that as well. So we're going to measure the frequency at the CN8 connector, volts and amps on the circuit formed by on the CN2 connector, pins 1 and 5 for the compressor inverter. All right, so we're going to be looking at the voltage between pins 1 and 5 of the CN2 connector on the main board. And let's find where those are. I like to scope it out in advance. If you look down here, it's super tiny, but it says CN2. And I know if you can't read that, you just got to take my word for it. All of these are labeled. In fact, underneath here even, it's labeled comp at pin 5 and neutral at pin 1. So it's just a matter of them. They've got convenient metal tabs up here, so we're just going to measure from 1 to 5, right? 1 to 5. It's as simple as that. So we can measure voltage between those points, and we can pick any one of these accessible wires. In this case, I'm going to pick the one going to pin 1, this one, and we're going to measure amps. Then we're going to go down to CN8, little 2-pin connector. Again, you got to look around. Oh, here it is. And it says CN8. Hard to see, but it does say that. And then we'll have to use special adapters on my meter to get in, to be able to back probe this connector, and then be able to make my frequency measurement. And I'll show you those special connectors. All right, so I'm just getting my amp meter set in place here, and I'll do my voltage measurement from pin 5 to pin 1, like that. And then to measure frequency up at CN8, that little connector, I'm going to use these Pomona leads. Fluke makes some, Pomona makes some. They're great, and they're made just for situations like this, where you want to come up and back probe these tiny little connectors. And I'm just back probing these little needles into, get good metal on metal contact in there, into that connector, and then I'll be able to measure frequency. Right now, we're not plugged in. We're going to do that now while we monitor volts and amps on the compressor circuit. All right, so here, amps. Right now, nothing. You do hear noises, listen. We've got dampers opening, we've got different fans testing themselves out. There's a whole self-test going on right now that it's doing. And it will, once it finishes the boot up process for the computer here and testing its peripheral components, then it'll start running the compressor. And we'll know when it starts running the compressor because we'll start seeing amps on the inverter circuit. All right, and we heard a little wind up noise. I don't know if you heard that. I don't know if that came through, but that's a subtle little noise. I mean, these sound very different from your split phase compressors that would have huge inrush current. Look at our amps. So 1/2 amp. You know, maybe started out at 0.6. Now we're down around 1/2 amp. As it settles down, it may go down even a bit further. So very low amp draw, very quiet running compressor. And so if we got amps, we got volts. So there's no need to measure the voltage, but we'll do it anyway, just for grins, just to show you that I can back probe on there and look at my meter. There. And that's on VAC. Let's look at it on on low Z. Good. We got a good 120 volt power supply, which we would expect. We're getting amps. So now, that was just showing you that for grins. Now we're going to go up and look at frequency. Okay, this is a special setting on your meter. On this one, I go to volts and press the yellow tab to get into hertz. And then I got to do this little thing up here again. Okay, let's look at our frequency. 110 hertz. The only spec they gave us was that it's stable, which it is. Now, as the frequency decreases, is the pulse width modulated signal, so it's actually just a square wave. Your meter calls it out as AC. Don't worry about that. You're interested in hertz. It's just a frequency of 110. You're interested in the hertz being stable, and as the frequency goes down, the speed of the compressor goes down. So, but right now it's just running flat out, and we'll probably be doing that for a few minutes. So these are just quick ways of using the schematic to figure out a easy access, minimal disassembly way of at least telling you, is my compressor running? When you have something like this, you can do your testing from the board, and by every indication, the compressor is totally running within spec. So the problem lies elsewhere. To be continued.